Okay, good morning everyone. Today we'll study Bohr Bury rule, or either you can say N plus L rule. Okay, now 11th class, ये rule आया क्यों? What's the need of this one? Actually, this rule is, you can say this rule was the answer. Okay, but एक छोटा सा defect था किसमें? That one is in of Bohr principle. Defect भी नहीं कह सकते, we can't say it's a defect, but वो थोड़ा सा कुछ observation था. If you remember, अगर हमें थोड़ा सा याद तो हमने क्या भरा था? 1s, then 2s, then 2p, then 3s, then 3p, after that 4s, and then 3d, and so on. After that जो पूरा चल ही रहा है configuration, that one is there. Okay, so 1s, 2s, 2p. Now in this one, just see sequence 3, 3. तो ये बीच में क्यों आ गया 4s? And you know that one is 3 is smaller as comparison to 4. This one is third shell. This one is fourth shell. Okay, so in this one, the biggest question or the big question arises that why 4s is filled before 3d. क्योंकि बाकी जो देखे थे वो तो बाद में देखे, जो सबसे पहले नजर किस पे पड़ी वो इसी पे पड़ी कि that one is why 4s is filled before 3d. Okay, तो to short out this problem या इसका reason देने के लिए कि क्यों भरा है, okay, that one is there is a Bohr Bury rule, or either you can say N plus L rule. Okay, according to this rule, just see simple thing, greater the value. Okay, just see according to this rule, first is greater the value of N plus L of orbital, greater will be its energy. Means जितनी ज़्यादा n plus l की वैल्यू होगी उसकी क्या होगी, एनर्जी भी उतनी ज़्यादा होगी. ओके, दैट वन इज डायरेक्टली प्रोपोर्शनल. जस्ट सी सॉल्व नाउ, बिकॉज देयर वाज अ कंपैरिजन. जो फर्स्ट कंपैरिजन था वो किसका था? 4s एंड 3d. तो वी विल टेक एग्जांपल ऑफ 4s एंड 3d. नाउ जस्ट सी इन दिस वन 4s, इसमें हम कौन सा रूल लगा रहे हैं? दैट वन इज n plus l रूल. नाउ इन दिस n, नंबर ऑफ शेल, दैट वन इज 4 plus l. Okay, and you know in case of s the value of l is equal to 0, so their total is 4. In case of 3d, again use n plus l rule, that one is 3, then plus d, and if क्या कहते हैं, in case of d value of l is equal to 2, so that one is equal to 5. Okay, so simple, just see in this one the value of n plus l is higher. Okay, in this case this one is the value of n plus l is higher as comparison to 4s. It means energy is also higher in case of 3d. That's why 3d is filled before, that's why 4s is filled before 3d, क्योंकि इसकी energy कैसी है? That one is lower energy, and reason is because this sum of n plus l, the value of n plus l is lower for 4s as comparison to 3d. That's why 4s is filled before 3d. Okay, then wherever that छोटा वाला पहले भरा हुआ है, तो the same reason that you can explain with the help of Bohr Bury rule. That one is n plus l rule. This one is first statement of Bohr Bury. Now what about second statement? Okay, now just see, note down this. Okay, 11th class. Now just see first statement. Hope so that one is clear to you. Now this one is second rule. First rule easy. Okay, now second one, that is if two different orbitals has same value of n plus l, because obviously when you solve for n plus l, maybe two orbitals have same value. तो सेम उसने वही कहा कि अगर दो ऑर्बिटल्स की सेम वैल्यू है फॉर n plus l, then greater value of n indicates higher energy orbitals. जिसकी वैल्यू किसकी होगी? द वैल्यू ऑफ n, जिसकी ज़्यादा बड़ा n होगा, that indicates higher energy value. Okay, now just see for example, if 2p and 3s both are there, if you will solve for this, their value, if you will solve for n plus l, that one is 2, okay, plus 1, that is equal to 3. Okay, now if you will solve for 3s, that one is 3 plus 0, that one is also 3. Okay, now just see both the values are same. दोनों की values कैसी हैं? Same है. तो in that case what you have to see? You have to see number of orbit. Okay, or means you have to see number of shell. That one is okay. So which have greater number of n? That one is 3. Okay, so this indicates what ki their energy is higher, and this one is the lower one, less value of n. This indicates less energy. That's why 2p is filled before 3s, although both have same value of n plus l. So this one is your n plus l rule. Okay. Okay, 11th class. Now, after Bohr Bury rule, we have another rule. That one is Hund's rule of maximum multiplicity. Okay. Now, according to Hund's rule, what this rule says? That one is, according to this rule, electron pairing will not take place in orbitals of same energy, or you can say same subshell, just like P, D, F. Okay, that one is orbital of same energy until each orbital is singly filled. मीन्स अगर एक सिंपल सी लैंग्वेज में बात कर दें, वट एवर इज द सबशेल, इफ दे हैव सेम एनर्जी, अगर उनकी एनर्जी सेम है तो फर्स्ट इलेक्ट्रॉन विल फिल सिंगली एंड देन पेयरिंग अकर. ओके, देन see I'll explain with example. Okay, now in this one, before I'll explain this rule, one more thing. Okay, because it's talking about orbital, so S, P, D, F, how to represent that orbital, उसे represent कैसे करेंगे. Okay, now in case of S orbital, okay, that one is S is represented like this, single box along with single box. This one is S orbital. And how to fill electron, that one is one electron. When you know, in one orbital we can fill maximum of 2 electron. So if one electron is filled, showing upward direction means clockwise direction, this one is half filled. Okay, and if downward is there, so it means this S orbital is completely filled. Now in case of P, okay, you know how many orbitals are present in case of P? That one is 3 orbitals, 1, 2 and 3. Now remember one thing, because P subshell have 3 orbitals, it means all 3 have same energies. Okay, now just see in this one, if 3 electrons are filled like this, so it means this one is half filled, and when we will fill like this, so this one is completely filled. In case of D, we have to make how many boxes? 1, 2, 3, 4 and 5. Why? Because D orbital, D subshell have 5 orbital, and in case of F we have to draw 7 boxes, because okay, how many orbitals? 7 orbitals in case of F. Okay, so now like this. So according to this rule, okay, just see, according to Hund's rule, what he said कि if orbitals of same energy, अगर जो subshell है, if they have same energy, तो first of all electron fills singly and after that pairing occur. Now just see for example, in case of phosphorus. Now phosphorus is 9, 1s2, 2s2, 2p, 5. Now in case of this, just see, P electron have how many electron? 5. Okay, so when you will fill electron in this orbital, जब हम orbital में electrons को भरेंगे, okay, तो how many orbital in case of P? Okay, that one is 3 orbital. Okay, and how many electron in this case? That one is, it's a 2p5. So when you fill electron, so how to fill? First of all, 1 electron to 1 box, then second, then third. Okay, 1 1 1. Now 1 1 1 electron given in each orbital of same energy. तो अब इसके बाद इसमें क्या करेंगे? Pairing करेंगे. Now 4th one, then 5th one, and if 6th one is present, तो वो कहाँ आ जाएगा? इसमें आ जाएगा. Okay, now suppose another one is, you have 2p3. Suppose this one is 2p3, किसी का भी हमने ले लिया इसमें, it's a 2p3. So when you will fill electron in this one, so how to fill electron? Okay, now this one is 1 electron, okay, 1 electron and 1 electron, single single single. This one is a Hund's rule, you have to fill electron singly, then pairing occur. If you will do this, if you will fill electron like this, 1, 2 and 3, so this one is wrong. Okay, right pattern is this कि फर्स्ट ऑफ ऑल okay, subshells of same energy, okay, तो उसके orbitals कैसे भरेंगे? Singly filled, and once it is singly filled, then pairing occur. If you will fill like this, so this one is wrong. That one is according to Hund's rule of maximum multiplicity. Now one more thing is there for Hund's rule of maximum multiplicity. According to this rule, okay, half filled and full filled orbitals are extra stable. Okay, जो आपके half filled and full filled orbitals हैं, they are extra stable. Okay, half filled and full filled means, you know, in case of P, that one is P, P3 is half filled. Okay, and P, this one is half filled, this one is half filled like this. Just see, it's a 1, 1 and 1. Okay, now P6, it's a 1, 2, 3, 4, 5 and 6. This one is full. Okay, so this one is half filled and this one is full filled. The half filled orbitals and full filled orbitals are extra stable as comparison to normal one. In case of D, D5 is half and D10 is full. In case of F, F7 is half, F14 is full. Okay, the half filled and full filled configuration are extra stable. Okay, now question arises, why half filled and full filled orbitals are extra stable. Okay, note on this. Okay, 11th class, now just see. Your question was, that is why half filled and full filled orbitals, or either you can say configuration, are extra stable as comparison to other. Okay, that is because of two reasons. One is that is symmetrical distribution of electron, and second is high exchange energy. In case of symmetrical distribution of electron, now just see, in case of suppose D5, now just see, this one is 1, 2, 3, 4, 5. Okay, if it's a half filled configuration in case of D5, okay, so just see, there is a symmetry in case of distribution of electron, even in case of, okay, that one is fulfilled also, 1, 2, 3, 4, 5, 7, 8, 9 and 10. This one is fulfilled. Okay, so just see, either it's a half filled or fulfilled. In both the cases, just see, that one is symmetry of distribution of electron is there. But in case either you can take D3, okay, you have to make all full 5 orbital, but electrons are distributed only in 3 orbitals, 2 are remaining. So distribution is not symmetrical, it's unsymmetrical, but here symmetry is there. The one reason for their stability is that one is symmetrical distribution of electron. Now second one is, that is because of exchange energy. Okay, actually in case of half filled and in case of half filled orbitals, okay, full filled में तो पूरे ही अपने भरे हुए हैं. In case of half filled of orbitals, then they can exchange their energy electron with another orbitals of same subshell, okay, in larger number of ways. That's why they have high exchange energy. Now just see, for example, if there is D5, okay, in case of half filled, so how many possibilities are there? Just see, it's 1, 2, 3, 4 and 5. 1 electron, 2, 3, 4 and 5. So now just see, this electron will exchange with this orbital also, okay, along with this also, okay, along with this also, and along with this also. So 1, 2, 3, 4. Okay, so like this, exchange energy kitni ho gayi itne time. Now in case of this one is when first electron is exchanging. Now if it is for second one, now just see, exchange energy, okay, 1, 2, 3, okay, like this, okay, 4, 5, then 6, 7. So like this way, okay, they can exchange their energy in larger number of ways. That's why their exchange energy is very high, and that is the reason that half filled and full filled orbitals are extra stable. One because of symmetrical distribution of electron, and another one is high exchange energy in case of half filled orbitals. Okay, so this one is about both the rules. Okay, thank you.